Part 1.
Part 1.
You will hear a conversation between Harry and Andrea, two students who have just finished their final exams. First, you have some time to look at questions 1 to 5. Listen carefully to the conversation and answer questions 1 to 5.
Hi Andrea, how are you feeling now that exams are over?
It's fantastic to have finished, isn't it? And to sleep in every morning. What about you?
Well, I've been catching up on sleep too, but I've got a lot to do before I leave for England. Perhaps you could give me some advice. I've got a lot of things I can't possibly take back with me, but I don't know what to do with them.
Well, it depends on what sort of things they are and whether you're thinking of giving them away or selling them.
Well, almost everything. Furniture, the fridge and other kitchen stuff that I bought from the previous tenant. But the new people have already got what they need, so they're not interested in buying stuff from me. I can't afford to give it away, but I'm not sure how to sell it all. Oh, and there are some clothes and books as well.
Why can't you take them?
The books are really heavy. It's so expensive if you exceed the airline baggage allowance. And the clothes just won't all fit in my suitcase. It's amazing how much stuff I've accumulated since I've been here. Anyway, I don't think I'll need as many summer clothes in England as I have here in Australia.
I see. Well, there are several alternatives. First of all, you could put up notices around the university about the books. You know, on the notice boards in the Student Union building and in the economics department. Anywhere second and third year students will see them. People are always keen to buy cheap textbooks.
OK, what should I say on the notices?
Just put the titles, authors and price you want, your name of course, and maybe put your phone number on those little tear-off tags.
That's a good idea. And what about the furniture?
You could try doing the same thing, but usually students are away all summer, so they don't want to buy furniture now. Another place to try might be a second-hand shop. Someone from the shop will usually come around and give you a free quote, and then you can decide. But you don't usually get much money for that sort of stuff.
Before you hear the rest of the conversation, you have some time to look at questions 6 to 10.
Another alternative is to put an advertisement in the Trading Post. Do you know that paper? It comes out every week advertising things people want to sell. You have to pay to put the advert in and then hope people phone. Give them as much information as possible, and if they're interested, invite them to come and have a look. The hard part is agreeing on a price.
No, I haven't seen the Trading Post, but I should have a look at it. And I could advertise the fridge, the microwave and the furniture. But the kitchen stuff isn't really that good. You know, old cutlery, a few pots and pans and some plates and things. What shall I do with them?
Well, another option is to donate the kitchen things to a charity shop. You know, like the Salvation Army or St. Vincent de Paul. Why don't you get a second-hand shop to give you a quote first?
Yes, I could do that. Find out how much they'll give me and then decide whether to sell them or give them away. But I've still got the clothes.
A charity shop will take them too, as long as they're in good condition. And even though you don't get any money, at least you know that someone who really deserves some help has benefited.
That's a good point. I'll advertise the expensive stuff, the furniture, and donate the clothes and kitchen stuff. Let's go and buy a trading post and you can help me write the advert.
Well, actually, I'm interested in buying the fridge and the microwave, depending on the price, of course.
OK, let's see how good you are at bargaining.
That is the end of part 1.
You now have half a minute to check your answers.
Now turns to part 2. Part 2.
First, you have some time to look at questions 11 to 17. Now, listen carefully and answer questions 11 to 17.
Good afternoon, everyone, and welcome to this short talk on the subject of fireworks. Now, fireworks, as I'm sure many of you know, were invented in China, though there has long been disagreement as to exactly when, or even in which century. The consensus nowadays, though, is that it was in the 6th, as there is considerable evidence of war rockets being made then. We also know that fireworks were in use by the 7th century in Arabia, where they were called Chinese arrows, reflecting their military potential. It then took a long time for them to spread to Europe. In fact, it wasn't until the 1200s that fireworks made their appearance there. The basic ingredients of fireworks have changed little to this day. Their explosive capacity comes mainly from black powder, also known as gunpowder, which is produced from a mixture of charcoal, sulfur, and potassium nitrate. A modern aerial firework, the kind used nowadays in big public displays, not the small rocket type that you might remember from your childhood, is normally made in the form of a shell, often a sphere about the size of a peach. Inside the shell are a number of stars, surrounded by black powder, and running through the centre of the round shell is a charge that makes the firework explode when it reaches the desired altitude. This is known as the bursting charge. When this explodes, it ignites the outside of the stars, which begin to burn with bright showers of sparks. Since the explosion throws the stars in all directions, you get the huge sphere of sparkling light that is so familiar at firework displays. A shell of this kind is launched from a 75mm diameter mortar, which in some ways resembles the type used by the military. The mortar is a steel, or increasingly for safety reasons, shatterproof plastic pipe. This is likely to be 500mm long and sealed at one end. The other end is aimed at the sky, and at the bottom of the pipe, below the shell, is placed a cylinder containing black powder. This has a long fuse, which projects out of the tube. When this is lit, it quickly burns down to the lifting charge, which explodes to launch the shell. In so doing, it also lights the shell's fuse. The shell's fuse burns while the shell rises to its correct altitude and then ignites the bursting charge so it explodes.
Before you hear the rest of the talk, you have some time to look at questions 18 to 20. Now listen and answer questions 18 to 20.
More complicated shells are divided into sections and burst in 2 or 3 phases. Shells like this are called multi-break shells. They may contain stars of different colours and compositions to create softer or brighter light, more or less sparks, etc. Some shells contain explosives designed to crackle in the sky, or whistles that explode outward with the stars. The sections of a multi-break shell are ignited by different fuses, and the bursting of one section ignites the next. The shells must be assembled in such a way that each section explodes in sequence to produce a distinct, separate effect. The pattern that an aerial shell paints in the sky depends on the arrangement of stars inside the shell. For example, if the stars are equally spaced in a circle, with black powder inside the circle, you will see an aerial display of smaller star explosions equally spaced in a circle. To create a specific figure in the sky, for instance a heart shape, you create an outline of the figure in stars inside the shell. Then you place explosive charges inside those stars to blow them outward into the shape of a large heart. Each charge has to be ignited at exactly the right time, or the whole thing is spoiled. Many other shapes have particular names, like the willow. This is formed by stars that fall in the shape of willow tree branches, spreading a little to the side and then downwards. The high charcoal composition of the stars makes them long burning, so they may even stay visible until they hit the ground. The ring shell is fairly basic. It is produced by stars exploding outwards to produce a symmetrical ring of coloured lights. More complex is the pattern created by the palm, which contains large comets or charges in the shape of a solid cylinder. These travel outwards, explode and then curve downwards, like the limbs of a palm tree. The serpentine, the last one for now, is different again. When this one bursts, it sends small tubes of incendiaries scattering outwards in random paths, which may culminate in exploding stars. It can be quite spectacular.
That is the end of part 2.
You now have half a minute to check your answers.
Now turns to part 3. Part 3.
First, you have some time to look at questions 21 to 26. Now listen carefully and answer questions 21 to 26.
Good evening, and welcome to this month's Observatory Club lecture. I'm Donald Mackey, and I'm here to talk to you about the solar eclipse in history. 1,000 years ago, a total eclipse of the sun was a terrifying religious experience. But these days, an eclipse is more likely to be viewed as a tourist attraction than as a scientific or spiritual event. People will travel literally miles to be in the right place at the right time to get the best view of their eclipse. Well, what exactly causes a solar eclipse? When the world goes dark for a few minutes in the middle of the day. Scientifically speaking, the dark spot itself is easy to explain. It is the shadow of the moon streaking across the earth. This happens every year or two, each time along a different and, to all intents and purposes, a seemingly random piece of the globe. In the past, people often interpreted an eclipse as a danger signal heralding disaster, and in fact, the Chinese were so disturbed by these events that they included among their gods one whose job was to prevent eclipses. But whether or not you are superstitious, or take a purely scientific view, our earthly eclipses are special in three ways. Firstly, there can be no doubt that they are very beautiful. It's as if a deep blue curtain had fallen over the daytime sky as the sun becomes a black void surrounded by the glow of its outer atmosphere. But beyond this, total eclipses possess a second, more compelling beauty in the eyes of us scientists, for they offer a unique opportunity for research. Only during an eclipse can we study the corona and other dim things that are normally lost in the sun's glare. And thirdly, they are rare. Even though an eclipse of the sun occurs somewhere on Earth every year or two, if you sit in your garden and wait, it will take 375 years on average for one to come to you. If the moon were any larger, eclipses would become a monthly bore. If it were smaller, they simply would not be possible. The ancient Babylonian priests, who spent a fair bit of time staring at the sky, had already noted that there was an 18-year pattern in their recurrence, but they didn't have the mathematics to predict an eclipse accurately.
Before you hear the rest of the talk, you have some time to look at questions 27 to 30. Now listen and answer questions 27 to 30.
It was Edmund Halley, the English astronomer, who knew his maths well enough to predict the return of the comet, which incidentally bears his name, and in 1715 he became the first person to make an accurate eclipse prediction. This brought eclipses firmly into the scientific domain, and they have since allowed a number of important scientific discoveries to be made. For instance, in the eclipse of 1868, two scientists, Janssen and Lockyer, were observing the sun's atmosphere, and it was these observations that ultimately led to the discovery of a new element. They named the element helium after the Greek god of the sun. This was a major find because helium turned out to be the most common element in the universe after hydrogen. Another great triumph involved Mercury. I'll just put that up on the board for you now. See, there's Mercury, the planet closest to the sun. Then there's Venus, Earth, etc. For centuries, scientists had been unable to understand why Mercury appeared to rotate faster than it should. Some astronomers suggested that there might be an undiscovered planet causing this unusual orbit, and even gave it the name Vulcan. During the eclipse of 1878, an American astronomer, James Watson, thought he had spotted this so-called lost planet. But alas for him, he was later obliged to admit that he had been wrong about Vulcan and withdrew his claim. Then Albert Einstein came on the scene. Einstein suggested that rather than being wrong about the number of planets, astronomers were actually wrong about gravity. Einstein's theory of relativity, for which he is so famous, disagreed with Newton's law of gravity in just the right way to explain Mercury's odd orbit. He also realized that a definitive test would be possible during the total eclipse of 1919, and this is indeed when his theory was finally proved correct. So there you have several examples of how eclipses have helped to increase our understanding of the universe. And now let's move on to social.
That is the end of part 3.
You now have half a minute to check your answers.
Part 4.
You are going to hear a lecture about dorm rooms. First, you have some time to look at questions 31 to 40. Now listen to the tape and answer questions 31 to 40.
Welcome to your new home for the upcoming year. These dorm rooms are among the best in the nation and are the newest ones at this school. So I hope you will all learn to appreciate them and take good care of all the facilities here. I am Gina, and I will be residential advisor in this building for the year. Today I am going to tell you about some of the programs and facilities that are available to you. I will also be telling you the rules that everyone is expected to abide by. I will be asking you to give me your full attention for the next few minutes. I will first tell you about the facilities that are available to you. The dining facility is located on the first floor of the building. It is open 7 days a week from 7 a.m. to midnight. All the food offered to students is freshly made every day, and my own opinion is that the food is actually quite good. Feel free to come and grab a banana for breakfast or sit down with a group of friends for dinner. Although your meals are served buffet style, please do not waste food. All students are expected to clean their own tables after meals. In the basement of this building, there is a gym and recreational hall. The gym has workout equipment such as treadmills and weight sets. In the recreational hall, there are ping pong tables and a pool table for student use. You must sign in when using this equipment, and you will be held responsible for any damages or losses. The gym and recreational hall are open daily from 10 a.m. to 10 p.m. There is a kitchen located on the second floor of this building. Your dorm key will open this door. Inside there is a refrigerator, a microwave, an oven, and a stove. This room is open 24 hours a day, 7 days a week. If you decide to cook a meal, please be considerate to all the students and clean up after yourself. You can use some food in here, but please do not make a mess. Some students do end up having their food eaten from the fridge, so be careful. Don't leave anything that looks like it tastes really good. Do not leave pots and pans lying around in the kitchen. Please store these in your room. There are many programs being sponsored by our building this year. One of the most popular is our Saturday morning outings. In the past years, these trips have included going fishing, hiking, cycling, ice skating, and even going to the beach. There will be a listing of scheduled events coming out soon. The university sponsors these trips, so transportation will be provided. However, there are usually some costs associated, though they are usually minimal. Our building also has a volleyball team. All students who live in this building are welcome to join. Last year we won first place in the dorm league. Please sign up at the front desk if you are interested as soon as possible, as there are only 20 spaces available based on a first-come, first-served rule. The last things I want to talk about are the rules of our building. I know rules can be boring, but they are necessary to ensure the welfare of everyone living here. First, noise levels must be kept to a minimum after 11 p.m. Many students have early classes, so for those of you that have the luxury of sleeping until 10, please don't stay up late making lots of noise. Secondly, all visitors must sign in at the front door. Even if you have friends that are regular visitors, they must still always sign in. This rule is to prevent theft and robbery from occurring. Thirdly, alcohol and drugs are not permitted in this dorm in any place or at any time. Lastly, just be safe and have a great time. University is the greatest time of your life, so make the most of it. Thank you all for your attention.
That is the end of part 4.
You now have half a minute to check your answers.